Hello everyone, this is Hippo. Today we will continue to learn A-level math chemistry, 3 and 3D. So first is the Hess's diagram. This is about enthalpy change. You will learn it in the chapter 6. So for the sodium solid to become the sodium ion and chlorine ion, it is need to add water. But if it's just like this, they'll all be gas. But if we use the lattice energy, this arrow will be reversed because the lattice energy is the ion to form a ionic compound. Okay, for the exothermic or endothermic, determined by the strength of ionic bonding and the energy released when break. The exothermic is the energy released, and the endothermic is energy intake. You have to learn it in IGCSE. Is that it? So for the physical properties of the ionic compound, you have to remember this. They have high melting point because there are big electrostatic attraction between the positive ions and the negative ions. So they have high melting point. A large amount of energy must be put in to overcome the strong electrical attraction and the separating ions. And second, their strengths but brittle, easily to be break, because any dislocation leaves any layer moving and similar ions being adjacent. The repulsion splits the crystal. We always positive ion attract the negative ion, like this one. But if we break this like this one, but if it's like this, the same sign will repulsion, so it will break. And second, it don't contact when solid because air will held tightly in the giant ionic lattice and can move. And when the molten aqueous solutions, the ions are free to move, called delocalized ion or free to move ion. And fourth is solubility. Insoluble non-polar solvent put soluble in water. Water is a polar solvent and stabilize the separated ions. You will learn it in chapter 7. It's about London force dispersion. Much energy is needed to overcome the electrostatic attraction and separate the ion stability. Attained by being surrounded by polar water molecules compensate for this. Okay, 3D. It's the strength of a bonding. Also, I have taught you before, there's a charge of metal cation, increase greater attraction between ions and delocalize the electrons. Oh, it's about metallic bonding. Okay, and the second is the size of the cation, closer between nucleus and the electron. Third is the number of delocalized electron per cation is called the electron density per cation. Therefore, for the magnesium ion, there are 2 delocalized electrons per atom.